This video is going to provide a short review of how to do a related rates problem in the context that you might see on the AP Calculus exam. So first, I just wanted to remind you that related rates are basically derivatives taken with respect to time. So no matter what variable it is, when you take the derivative, you'll do d, whatever that variable is, and then dt. So that's different from doing like dy dx. So for example, if you had to start off with something like y squared equals x squared plus 3, then when you took its derivative with respect to t, you would get 2y because that is the derivative of y squared, but then you would attach dy dt to it. And then when you did the derivative of x squared, that would be 2x times dx dt. But then the derivative of the 3, which is constant, would still be a 0, so you wouldn't need anything for that. Some keywords that you'll typically see in a problem that will kind of it could be a tip-off that you'd want to do related rates would be asking for a rate specifically with respect to time. That is a big keyword, especially if time hasn't been a part of a problem so far. And also the phrase at this instant, because you should remember from studying related rates problems in class that they give you basically a way to relate the speeds that two different things are changing. And then it always has to be at the same moment in order to be able to relate those rates. So what I'm going to do is I'm going to, as an example, record myself doing a piece of an actual AP exam problem to kind of remind you how this might work. So the problem that I'm going to do is from the 2016 AP Calculus exam, and it's this problem about a funnel. So I'm only going to do the part of this problem that actually is a related rates problem. So it starts out with a diagram of a funnel, and it tells you that it has a height 10 inches, it has circular cross sections, and at any height, the radius is given by the equation that they give for the heights between 0 and 10. So the equation given relates r, radius, and h, height. Part A says find the average value of the radius of the funnel. So that's not a related rates problem, so we're going to skip part A. And then part B says find the volume of the funnel. That's not a related rates problem, so we're going to skip part C and part B. Part C says the funnel contains liquid that is draining from the bottom. At the instant, that's a keyword for related rates. When the height of the liquid is h equals 3 inches, the radius of the surface of the liquid, so that's the r in this scenario, is decreasing at a rate of 1/5 inch per second. And then notice it says at this instant, again, what is the rate of change of the height with respect to time? And so, especially because they're saying with respect to time, that is, again, your tip-off that you want to do a related rates problem here. So since they're asking for the rate of change of the height with respect to time, I'm just going to move this page up a little bit here. That is dh, because it's rate of change of the height with respect to time, or dt. So they're looking for dh dt here. And the big thing to realize is you also have some information about h. So in the problem, they tell you that h equals 3. And they also tell you that the radius is decreasing at a rate of 1/5 inch per second in this situation. So that's telling you that dr dt equals, and this is an important thing, negative 1/5 because of the decreasing. So they give you they give you dr dt, and they want you to find dh dt, which means you want to start by taking the derivative of an equation that has r and h in it. And so luckily we have that. That's the given equation, 1/20th 3 plus h squared. And what I want to do is just take the derivative of this with respect to t. Before I do that, I am going to multiply out the coefficient of 1/20th because that's going to make it a little bit easier to take my derivative. And I'm also going to, while I'm writing, just mention that when you studied related rates during the normal part of the year, one of the trickiest parts was often the setup of the related rates problem because it usually had to do with some tricky geometry. In a lot of AP exam questions, you actually don't have to set up the primary equation that you take the derivative of. It's often given. So in this case, the r equals 1/20th 3 plus h squared is given. All you have to do is actually just do the calculus of taking the derivative. So when I take my derivative, I'm going to say that the derivative of r is dr dt. The derivative of 3/20ths is 0, so I'm not going to write anything there. The derivative of 1/20th h squared is going to be 2 over 20 using just power rule, and then h, and then again, because it's related rates, I'm going to write dh dt at the end. So now this is my to solve for. I know that h is 3 because that was given in the problem. And I also know that dr dt is negative 1/5 because that was given in the problem. Again, remembering that negative because it was decreasing. So what I can do is I'm just going to go over to the side and I'm actually going to solve for dh dt, which is going to be pretty easy. I'm going to say that negative 1/5 is equal to 1/10 because I'm reducing the 2/20 times 3 times dh dt. I'm going to multiply both sides by 10/3 to cancel out what I've got on this side. So all that's gone. And I'm going to end up, if I cancel, make that a 2 and make that a 1, I'm going to end up with negative 2/3 equals dh dt. And if I wanted to just answer that question, it does not say that I have to use units. So I can just finally answer that question by saying that the rate of change of the height with respect to time is simply negative 2/3 because I don't have to say it's decreasing. I can just say the rate is negative 2/3 and I don't have to use units. Although if I wanted to, it would be inches per second since the height is in inches and the time is in seconds.